This is the brief on the geometry and dynamics of the magnetic dipole field. Okay, so we're looking at what happens when abstract math, kind of crashes into physical reality. We're going to calculate a magnetic field from the ground up just to see what it actually looks like. First up, the math. You start with this mathematical blueprint. It's called the vector potential to predict the field's shape. And what you get is this cool butterfly pattern where the field points downward along the axis and then, well, it fades away incredibly fast the farther out you go. Second, though, you hit a snag. The math shows these field lines pointing down and just ending. But physics has a hard and fast rule. Magnetic lines cannot just stop. They have to form closed loops. So to make it all physically consistent, those downward lines have to snap right back upward through the core. And finally, this is what explains the solenoidal nature of the field. And that's really just a fancy way of saying nothing's lost. That singular flow shooting up the center perfectly balances all the return flow on the outside, turning an abstract math point into a real finite current loop. So while the math predicts that rapid drop-off on the outside, physical laws demand that continuous upward flow on the inside to close the loop. True understanding comes from reconciling that abstract singularity with the reality of a finite physical loop.